Hello, how are you doing? I am Dr. Ahmed Bathaini. In the last video, we explained the process in which both male sperms and female ovums form. In this video, we will take a closer look into inside the location where these processes happen and talk a little bit about the hormones that affect these processes. As we can see, the sperms are produced inside the semi-nephrotic tubules, and this here is a section inside a semi-nephrotic tubule. It's composed of 4 layers of cell. The most important one is the innermost layer of cell, which is called serotoli cells, and these are the cells that we are interested in today's lecture. As we can see, serotoli cells contain tight junctions in between them. When we zoom in into these tight junctions, we notice that they form 2 compartments, one beneath them and one into the inside. This compartment into the outside of the tight junctions is called the basal compartment, and to the inside is called the abdominal compartment. In the basal compartment, there is the spermatogenesis undergoing mitosis, dividing into 2 identical cells that resemble the parent cell each time, and only half of the spermatogenesis that form pass into the abdominal compartment to start the meiosis process, and it is resembled here in this picture by one spermatogenesis forming 4 sperms. In order for this process to happen, we need 2 major hormones, the FSH and LH. These hormones are produced by the hypothalamus, and then when they go to the semi-nephrotic tubules, they work in 2 cells to help them produce 2 essential hormones, which are the testosterone. Testosterone is increased by the luteinizing hormone, which is LH, affecting the Leydig cells to transform cholesterol into testosterone. On the other hand, the follicular stimulating hormone, which is the FSH, works on the serotoli cells to produce the androgen binding hormone, and these testosterone and androgen binding hormones are very important and essential to activate the process of meiosis. And that's it in the male side. That's where the spermatogenesis happens, and these are the most important hormones, and this is the most important cell. Let's go now to the female side and discuss the oogenesis. Okay, so now here is the female side. The oogenesis happens inside the ovaries, and it is very different from spermatogenesis. In the ovaries, there is thousands of primordial follicles containing primary oocyte. As you can see, this green layer of cell resembles the primordial follicle, and this blue cell resembles the primary oocyte. There is thousands of this inside the ovaries, existing in the female even before birth. And after the female reaches puberty, some local androgens start to act on these primordial follicles, transforming them from primordial follicle into primary follicle, one by one each month, transforming it into primary follicle. The first change happens in the primary follicle. The oocyte is still primary oocyte, it didn't change. And then by the effect of other hormones, this primary follicle transforms into secondary follicle. The secondary follicle contains a sac. This sac contains a fluid, which is hyaluronic acid, and at this stage, the primary oocyte produces a layer of glycoproteins around it called the zona pellucida. So in the second stage, we transform the primary follicle into secondary follicle, and the primary oocyte produces the zona pellucida. As you can see, in the first 3 steps, the primary oocyte is still primary oocyte. It didn't change into secondary oocyte. It still didn't undergo meiosis 1. But in the last step, the primary oocyte transforms into secondary oocyte, and multiple cells form around it. The innermost layer is called the corona radiata. The corona radiata then will pop out with the secondary oocyte from the Graafian follicle, and then get collected by the fallopian tube, and there it will stay as secondary oocyte until sperms show up. So in this last step, what are the changes that happen? The secondary follicle formed Graafian follicle. The secondary oocyte has corona radiata and the zona pellucida. Then the Graafian follicle causes the secondary oocyte to pop out and get collected by the fallopian tube. Both the secondary oocyte and the corona radiata around it go to the fallopian tube and stay there without any change until the sperms arrive. Okay, all these steps cause the production of estrogen. Now let's talk about the hormone that affect this process. First, the transformation of the primordial follicle into primary follicle is affected, as we said, by local androgen. Then the other steps are affected mostly by follicular stimulating hormone, and less importantly by the luteinizing hormone. During these steps, estrogen is produced, and estrogen will do major changes in the uterus wall, causing the lining to grow and thicken to prepare the uterus for pregnancy. And that's it for this lecture. Please make sure to subscribe to watch our next videos. There will be a series to explain and highlight the major events in the embryology in order to form a strong foundation for the student to be able to build the more detailed information that they take in their classes upon this foundation. Thank you so much. Like, share, and subscribe, and see you in the next video.